Okay, so what we're going to have a look at in this lecture is solving linear equations, okay, the basics behind solving linear equations. So when we're looking at linear equations, this is an example of what one might look like, okay. Now with linear equations, we only have one answer, okay. We have different types of equations, such as quadratic equations, which we'll look at further on in the course. And with a quadratic equation, for example, you'll have two answers, okay, but there's only one answer that satisfies this equation. So by satisfying this equation, what I mean is that this side will be equal to this side. Okay, so there's only one number we can put in for x here, which is the variable that we're solving for. There's only one number that we can put in that will make this side equal to this side. Okay, hopefully you can see, hopefully you can guess that x in this case is 3. Okay, so if we put x equals 3 in here, just by substitution and a bit of guesswork, an easy bit of guesswork, we can see that we get 21 equals 21, so this satisfies the equation. Okay, now naturally, most linear equations that we look at, you can't actually just guess, okay? They're a bit more difficult than that. In this case, it's quite an easy one to guess, isn't it? So how do we go about solving these equations then if we can't guess? Right, so what we're looking at trying to do then is get x equals to whatever else. Okay, so the answer, we want to look something like this, okay? X equals to a number. Now, the way we can do this is by manipulating the equation. Now, what I mean by that is we can either multiply the equation by a number or divide the equation by a number to get x equals to something else. So in this case then, to get x equals to a number, we want to get rid of this 7 here that's in front of the x. Okay, now what can we do to get rid of this 7 in front of the x? Well, what we can do is we can divide this by 7, can't we? Because if we divide this by 7, can we see that 7s will end up cancelling? Okay, so if we've got 7x over 7, the 7s will end up cancelling. But when we're looking at equations, we can't just do whatever we want to one side without doing something to the other side as well. Okay, so what we've got to remember is when we're dividing one side of an equation by a number, we have to be fair to the other side of the equation and also divide that by a number. Okay, so in this case then, we've divided the equation by 7, but we divided both sides of the equation by 7. So what will happen in this case then, 7s will cancel on the left hand side, so we're left with x is equals to 21 over 7. Okay, and naturally then, stick it in the calculator if you're not sure, we get x equals to 3. Okay, so this gives us the answer to this equation. Now in a straightforward linear equation like this, it's quite easy to say, well, let's divide both sides by a number or multiply both sides by a number. But when the equations get a little bit more difficult, we need to look at something called cross multiplication. Okay, so this might seem a bit confusing initially, but trust me, it makes equations a lot easier to solve going forward. Okay, now what I mean by cross multiplication is if we've got something in this form, okay, we can take each of these terms diagonally through the equal sign. Okay, so I could take this a here down to the bottom right. I could take this b up to the top right. Or conversely, I could take this c down to the bottom left. I could take this d up to the top left. Okay, so this is what we call cross multiplication. I can fit it on my board. Cross multiplication. Okay, very important, and this is generally how I will be solving linear equations, and also when we get on to transposition of formula as well, it does make it a lot easier to manipulate. So if we're looking at this very basic equation then, 7x equals 21. What I would say, rather than dividing both sides by 7, I would say, okay, let's cross multiply this 7 down to the bottom right. Okay, so you could take the 7x down to the bottom right if you wanted to, but of course you'd be left with x's and numbers on the same side again. Okay, so it wouldn't actually solve the equation. As long as these terms are multiplied on the left hand side, you can take one of them down. Okay, one of them or both of them, it's up to you depending on the equation. So by cross multiplication then, we can go straight for it. We can say x is equals to 21 over 7, x equals 3. Okay, exactly the same thing. Now looking at a linear equation that's slightly more difficult then. For example then, 3x minus 2 is equals to 10. Now remember what I was saying, what we essentially want to be left with is x's on one side, numbers on the other. Okay, so you want to get all your numbers onto one side. Now it doesn't matter which side you take them onto, okay? People often ask me, is it okay if you've got x equals a number or a number equals to x at the end, yeah, with your answer? Makes no difference, okay? It doesn't matter which way you take your numbers and x's to, as long as you're consistent with your mathematics, okay, and the processes you're going through. Now we want to try and have 3x on its own on one side initially. And in order to do that, of course, we've got a problem here because we've got a minus 2 on this side also. So we want to get rid of this minus 2 on the left-hand side. Now, remember what we were saying before. Whenever we manipulate an equation, we've got to do the same on the left-hand side as the right-hand side, okay? We've got to be fair to the equation. Now, the long-winded way of doing this would be to say, well, okay, if we've got to do the same to both sides of the equation, we could add 2, couldn't we, on both sides of the equation? Because if we add 2 onto this side of the equation, look, we'll have minus 2 plus 2, and it'll cancel out on the left-hand side. Okay, so the long-winded way of doing it would be to say, well, okay, add 2 on the left-hand side, add 2 on the right-hand side. Okay, what we're left with then, of course, 3x is equals to, these 2's will cancel out, and we're left with 12 on the right-hand side. So can you see now, we've got an equation that looks pretty much exactly the same as the last question we had a look at. Okay, different numbers, but exactly the same. And remember what we did there then? We wanted to get rid of this 3 because we want to end up with x equals a number. So what we did is we cross multiplied this 3 underneath the 12. And of course then we're left with x is equals to 4. Okay. So dividing through here by 12, remember what we could have said, as in the last example, we could have said divide both sides by 3. Okay, exactly the same thing, but it would have been a bit more of a long-winded way of doing it. Okay, now the quicker way of doing something like this would be to manipulate this equation straight away. Rather than saying add this onto both sides, we can manipulate this equation, okay, terms in this equation. Now, starting again then, what we wanted to do, of course, is get this 2 onto the right-hand side, yeah, because we want to get all the numbers on one side, all the x's on the other. So in order to take this 2 to the right-hand side, what we've got to remember is whenever we take a term that's either added or subtracted on one side of the equation to the other, we have to change the signs. Okay, so very important little quote I tell my students is change sides, change signs. Okay, very important. Change sides, change signs. So taking this minus 2 to the right hand side then, remember we changed the signs, so bringing this minus 2 to the right hand side, it will change to a plus 2. Okay, so can you see we've got down to this 3x equals to 12. quite quickly, yeah, without all of this rigmarole of adding 2 onto both sides. Okay, and we're left with then x is equals to 12 over 3, x equals 4 once again. Okay, and remember, you can always check your answers with linear equations, with simultaneous equations, quadratic equations, any equations, okay, trigonometric equations when we get onto those. You can always check your answers by substituting this value, this answer, back into the original equation. Okay, so we got x is equals to 4 as the answer. So if I put this back into the original equation, so wherever there's an x, we're putting 4. And remember now, at this level of mathematics, we don't tend to use multiplication signs, okay? We tend to use these brackets instead, or parentheses. If you're from America, they tend to, and possibly even Europe, they say as well, parentheses. I'll call them brackets, easier to say. So we've got 3 times 4, which is 12, minus 2 equals 10. So we're left with 10 equals 10. So this equation then has been satisfied. Okay, so always a good way to check your answers. And I always say, particularly in exam situations, if you've got time at the end of an exam, always start to substitute your answers into the questions to see if you've got the right answer. Okay, nothing worse than leaving an exam, half an hour left on the table without checking your answers. Okay, because you can check there and then if you've got the right answer or not. Okay, so moving on to a slightly more difficult example then. Excuse me. In this case, we've got x's and numbers on both sides, okay? And by the way, if you want to pause the videos to have a little go at them before I get to the answers, then you're more than welcome to do so. So we've got 3x minus 5, x plus 15. Now, what we're aiming to do, as usual then, is get all the x's on one side, all the numbers on the other. Doesn't matter which side you take the x's onto and which side you take the numbers onto, you'll get the same answer at the end, okay? Some of your calculations might look slightly different. You might have minuses in your calculation instead of positives, for example, but you will get the same answer. So what we're looking at doing here then is getting all the x's onto one side. So I'm going to take the x's onto the left-hand side in this case. So we've got 3x, bring this x to the left, becomes a minus x. And on the right, we're taking this minus 5 to the right, becomes a positive 5. Okay, so let's group our terms together. 3x minus x equals 2x. 15 plus 5 is 20. And we're left with then x is equals to 20 over 2, which is equals to 10. Okay. Now, like I said, it doesn't matter which way you take your x's onto and which way you take your numbers onto. The reason I took the x's to the left in this case is that if you end up with a positive number in front of the x towards the latter part of your solutions, it makes it a bit easier in terms of this part here when you've got to divide through by this number. Okay, if you're ending up with a minus in front of the x here, people tend to forget to divide through by that minus number. Okay, so we can have a go at it. Let's take the x's to the right hand side for a change then, and hopefully we'll get the right answer, same answer. So I'm going to take this 3x to the right and this 15 to the left. Okay, we're going to do it the other way around just to prove that it works. So minus 5, this 15 comes to the left, becomes a minus 15. We've got an x on the right hand side here, and this 3x then is going to become a minus 3x. On the left hand side then, we've got minus 20 on the right hand side, so we've got 1x minus 3x, that will give you minus 2x. Okay, so it's this situation now that sometimes people will make a mistake on. They will divide through by this 2 here and think, there we go, we've got the answer, x equals to whatever. But of course, if you divide through by just the 2 here, what you're left with on the right hand side, you've still got that minus on the right hand side there. yeah, you're left with minus x is equals to, which will be minus 10 on the left hand side then, yeah. But of course we don't want to go through all of this rigmarole again. So what we want to do is, as we did on the last example, divide through by whatever's in front of the x. Okay, when you want to get x as an answer, always divide through by whatever is in front of that x, whether it's negatives, positives, whatever. Okay, so in this case we're going to divide through or cross multiply by the minus 2. And what we're left with then, minus 20 over minus 2, will again give us the same answer, okay, 10. So always remember then, when you're dividing negatives, you end up with a positive. Okay, so a quick little crib sheet here. A positive over a positive will give you a positive answer. Okay, plus VE, it's just shorthand for positive. A positive over a negative will give you a negative. Okay, unlike signs, as we say. And of course, conversely then, a negative over a positive will give us a negative. And a negative over a negative, just as we had on that example, will give us a positive. Okay, so here we've got like signs. Like signs give us positive, and unlike signs here will give us a negative. Okay, so be very careful with that, particularly when you put it in a calculator as well. I mean, put it in a calculator if you're not sure, but you should really get to remember and learn that like signs give you a positive and unlike signs give you a negative. Okay, exactly the same goes for multiplication. Of course, multiplication and division, very, very similar operations. When you multiply two positives, you get a positive. When you multiply two negatives, you get a positive. When you multiply a positive and negative, you get a negative, or negative and a positive, you get a negative. Okay, so it's the same situation with unlike signs. Let's have a look at another quick example, very similar to the last one. Okay, so if you want to pause the video and have a go at it. Right, so again then you want to get x's on one side, numbers to the other. So I'm going to take the x's to the left, numbers to the right. So we're left with then 5x, this becomes a plus x. 10 stays on the right hand side, of course. Minus 2 comes across to the right and becomes a positive. So we've got 10 plus 2 on the right hand side. On the left then, 5x plus x, 6x. 10 plus 2, 12. 12 over 6, which will give us 2. Okay, so very similar to the last one. But don't be put off, of course. Quite often people get put off with different numbers. You know, if you've got, say, 2x on one side instead of a 3x, don't be put off. And this goes with mathematics in general, okay? It's like learning a recipe, I say. Okay? Once you know how to do 1 or 2, the examples are very similar going forward. They might get a bit more difficult, but generally it's the same recipe. Okay, you always end up trying to get x's on one side, numbers on the other, and then dividing through by whatever's in front of the x. Okay, so looking at a slightly different one again then. So ramping up the difficulty slightly. So if you notice here then, we've got brackets involved. Okay, so all this means then is that we've got 3 multiplied by whatever's inside this bracket and 2 multiplied by whatever's inside this bracket. Okay, so don't let it put you off. All it's asking us to do here is multiply 3 inside this and 2 inside this. Okay, now what we've got to remember with linear equations, as we stated before, what we want to end up with is x's on one side, numbers on the other. Now, in order to do that, what we would like is separate terms on both sides. Okay, so we'd like something like this: 3x plus 5 equals 10, for example. We want to have separate terms, so if we add an x on the right as well, we want to have separate terms, and then we could take this to the right, the x to the left, for example. Okay, so this is the situation that we want to get down to, but we can't do that at the moment because we've got this number multiplied inside this bracket and this number multiplied inside that bracket. So in order to get down to that situation, what we want to do first is multiply these brackets out. Okay, generally, not all the time, but generally when you see brackets inside an equation, you want to multiply them out. Okay, especially with linear equations, this is what we want to do. Okay, sometimes with some equations, particularly with quadratic equations, for example, we want to have brackets in the equation, but in this case, we want to get rid of them. Okay, so in order to do that, then we multiply this 3 inside this bracket first, and we multiply this 2 inside this bracket second. Okay, so we've got 3x here. 3 times x will give us 3x. 3 times minus 3 will give us minus 9. Okay, so remember, positive multiplied by negative will give us a negative. And on the right hand side then we've got 2 times x, so that's 2x. And 2 times minus 1, so positive times a negative, we will get minus 2. Okay, so now this looks great because we've got separate terms. We can manipulate this equation now. We can take numbers to the right, x's to the left, or vice versa. So what I'm going to do then is take the x's to the left. So we've got 3x minus 2x. Yeah, so this becomes a negative. And this is equals to, on the right hand side, we've got minus 2 over there already. And when we take this minus 9 to the right, it'll become a positive 9. Okay, and people often ask me, does it matter that I've got the 9 here instead of in front of the minus 2? Doesn't make any difference. Okay, when you're adding numbers together or subtracting numbers, doesn't matter which order they're in. Yeah, so for example, 2 plus 1 is the same as 1 plus 2. Yeah, 3. Hopefully you all got that answer. Okay, so in this case, if I wanted to, I could have 9 minus 2. Okay, exactly the same thing. Right, so let's go for the answer then. 3x minus 2x is x, yeah, 1x. And on the right hand side, 9 minus 2 is 7. Okay, so there's the answer to that equation. And of course, again, you can substitute this into your answer and it should satisfy the equation. So if I substitute into the left hand side here, what have we got? 3 multiplied by 7 minus 3. On the right, we've got 2 multiplied by 7 minus 1. So 7 minus 3 is 4. So 3 times 4. On the right hand side, we've got 2 times 6. Yeah, 7 minus 1 is 6. So what do we end up with then? 12 is equals to 12. Equation has been satisfied. Right, so looking at a slightly more difficult example now. So notice we've got brackets on both sides here, but we've also got brackets with multiple terms multiplied by another bracket of multiple terms. Okay, so as with the last example then, remember what you're trying to do. You're trying to have separate terms. Okay, so the way we do this, as in the last example, we multiply each of these brackets out. Okay, slightly more difficult now because you've got multiple terms in each of these brackets. But what you've got to remember is that when you've got two brackets multiplied together like this, each term in this bracket has to multiply by each term in this bracket. Okay, so this x has to multiply by that x, and it also has to multiply by the 2. And this 4 has to multiply by that x, and also has to multiply by the 2 in the second bracket as well. Okay, so people tend to remember this as FOIL. Okay, so this stands for firsts, outers, inners, lasts. Okay, so this is telling us which terms to multiply together. So first ones in each bracket, the outer terms, so this one and this one, the inner terms, these two, and the last terms. Okay, so that's one way that people remember how to multiply something that is in this form. Okay, only works for something that's in this form. Of course, if you've got multiple terms in this bracket here, for example, if you had 3 or 4 terms in this bracket here, this wouldn't work then. Okay, because you would be missing out things to multiply together. Yeah, we wouldn't have terms in the middle. We'd have one missing in the middle as well if you had 3 terms in this bracket. Okay, so we'll look at brackets like that further down the line. But all you've got to remember is each term in this bracket multiplies by each term in that bracket. If you remember that, it doesn't matter how many terms you've got in each bracket. Okay, you could have 10 in each bracket and it would work. Right, so let's get back to solving this equation then. So we're multiplying out each term here. Each bracket, sorry. So we've got x times x, which ends up as x squared. Remember, when you're multiplying 2 terms together, x's in this case, you add the powers. So we've got x to the power 1 essentially here, x to the power 1 here, x to the power 1 times x to the power 1, you add the powers, will give us x to the power 2, okay, x squared. So x squared, and then we multiply x by the 2, so we've got 2x, 4 times x, and 4 times 2, which will give us 8. On the right hand side then, might run out of room here, we've got x times x, which is x squared, x times minus 2, which is minus 2x, 1 times x, which is x, and 1 times minus 2, which is minus 2. So sorry, I've had to squeeze it in a bit on the right hand side there. Okay, so now what we want to do then is try and simplify any terms. Okay, so what I mean by that is grouping together terms to make it look, well, simpler, as the name suggests. So on this left hand side then, we've got 2x plus 4x. So how many x's have we got? 6x. Okay, so on the left hand side then, 2x plus 4x will give us a 6x plus 8, of course. On the right hand side, we've got x squared. So we've got minus 2x plus 1x. So that'll give us minus 1x. Okay, so minus x. And of course, we've got the minus 2 left over on the right hand side. So if I draw a little line there so that it looks a bit clearer. Right. So the same thing then, we want to get the x's on one side, numbers on the other. But notice now we've got x squareds here. Now remember, x squareds and x's cannot be grouped together. Okay, they're entirely separate terms. If you were to put numbers into an x squared and an x, they would look totally different. Yeah, so say if you've got x squared here and an x here, if we put, say, x equals 2 into these, it'll give us a different answer, of course. Yeah, x is 2 there. X squared would be 2 times 2, which would be 4. Okay, so it would give us a totally different answer. So x squareds and x's can't be grouped together. Right, now to make this more straightforward again, can you see we've got an x squared on both sides here? Now whenever you've got the same term on both sides, we can cancel them off, okay? And by the same term, I mean exactly the same, not the same but with a minus in front of it, okay? They've got to have the same sign in front of it as well. So we can cancel them off. The reason being, of course, if I took this x squared to the left-hand side here, it would become x squared minus x squared, and they would cancel. Or conversely, if I took this x squared to the right-hand side, we'd have x squared minus x squared, and they would cancel on that side as well. Okay, so whatever side we take these onto, they're going to cancel. All right, so we've got an x squared on both sides. We can cancel them off. Now, if they didn't cancel off, we'd have to solve what is called a quadratic equation. Okay, what we've got on each side here is what we call a quadratic expression. Okay, so we'll go into that in a bit more detail when we look at quadratic equations. So what we're left with then is 6x plus 8 is equals to minus x minus 2. Again then, get the x on one side, numbers the other. If you notice, no matter what the equation looks like at the top here, it looks a bit more difficult, but we're still doing the same things towards the end of the equation. Okay, exactly the same things. Right, so let's take the x's to the left then, numbers to the right. So what we got, 6x plus x is equals to minus 2 minus 8. So we're left with 7x is equals to minus 10, which gives us an answer minus 10 over 7. Okay, so I don't mind you expressing your answer as decimals or fractions generally. The only time I would be fussy about that is if the exam question stated express it to one decimal place, for example. In that case, then this wouldn't be acceptable. Okay, you get most of the marks, but of course 1 mark on the end, you know, it would be dropped. Okay, and every little helps. Moving on then to slightly more difficult one, but same in terms of the layout of the solution. Slightly more difficult because we've got 2 x's in here now instead of x's. Okay, so the algebra is slightly more difficult. So again, then let's multiply these out. So what we got? 2x times x is 2x squared. 2x times 2 is 4x. Minus 1 times x is minus x. Minus 1 times 2 is minus 2. On the right hand side, we've got 2x squared plus 2x plus 2x plus 2. Okay, so a lot of 2x's in there. 2x squared plus 2x plus 2x plus 2. Right, let's tidy this up. So we've got 2x squared. 4x minus x will give us a 3x. And on the right, we've got 2x and a 2x will give us a 4x. Plus, of course, the 2 that was left over on the end. Okay, so same situation then. We've got a 2x squared on both sides, so we can cancel them. So they've gone, which makes this a lot easier to look at now. So we've got 4x plus 2 on the right. Usual thing then, numbers on one side, x's on the other. Now, in this case, I'm going to take the x's to the right, okay? So we've got, if we take this number to the left then, we've got minus 2 minus 2, and that's equals to 4x minus 3x. So we've got x is equals to minus 4, okay? Or minus 4 equals to x, same thing. So why did I take the x's to the right this time instead of the left? Well, again, it makes no difference. But remember I was saying about people forgetting to divide through by negatives. If we took the x's to the left, as we've been doing so far, and we had minus 3x minus 3x minus 4x, and 2 plus 2, yeah, because this minus 2 would come over, become a positive. We're left with then, on the left-hand side, minus x is equals to 4. Now, a mistake people make is they will say that that then is the answer, okay? But of course, this is minus x equals 4. I want to know what x is equals to. And don't forget, what we've got here is essentially minus 1x equals 4. Now, remember what we've got to do is divide through by whatever's in front of the x, okay? So we've got x is equals to 4 divided by minus 1. Positive divided by a negative, unlike signs, will then give us x is equals to minus 4. Okay, so same answer, but people will be unstuck with that one. And I see that quite a lot, regardless of your level of mathematics. Okay, so what I always think is when I get to this stage here, always try and get your equation so that you've got x as a positive on one side. Okay, so this usually determines which side I take my x's and numbers to. Doesn't make any difference, but it does negate some of the issues you might have further down the line here, and mistakes that you might come across. Okay, so next linear equation then, that looks slightly different now. So if you notice, we've got fractions on both sides. Okay, now it's the same situation in terms of getting the x's on one side, numbers on the other. But instead of having brackets as in the last one, now we've got fractions to deal with. So it's very similar in that we want to get rid of these fractions. Now, how do we get rid of these fractions? Well, we want to get these numbers on the top somehow. Okay, we don't want these numbers on the bottom here. And how do we go around that? We look back at, if you remember, cross multiplication. Okay, remember I can take these terms diagonally through the equal sign. Okay, so I can take this 5 up to the top right, and I can take this 3 up to the top left. And in doing so, these terms multiply by everything on the tops. Okay, so this is why it's called cross multiplication. When I take this 5 up to the top right, it multiplies by everything on that top right. Okay, and we don't change the signs in this case. When we're doing cross multiplication or multiplication in general of equations, we don't change the sign. Okay, we only change the sign when we're physically taking a term from one side and adding it on the other side, yeah, or subtracting it on the other side. Okay, so that's the only reason we change terms, change signs. So this 3 comes up to the top left, multiplies by everything on the top left. Very important that you use brackets. Okay, common mistake I see is people leaving brackets there, leaving brackets out, and then doing 3 times 4x, which is fine, but then they forget to multiply the 3 by the minus 3. Okay, so brackets, very important. Okay, you can't overuse brackets. Okay, put them in wherever you can. Right, take this 5 to the top right. So what have we got then? 12x minus 9 is equals to 10x minus 5. So if you notice now, this might be a step more, this cross multiplication, but we're on exactly the same type of question now as the last few. You've got something multiplied by something else. You've got to multiply them out to get separate terms. Okay, so in this case then, we can now manipulate this because we've got separate terms. We can take x's to one side, numbers to the other. I'm going to take the x's to the left. So we've got 12x minus 10x. And on the right, we've got this minus 5 plus 9. Okay, so what we're left with then, on the left-hand side, we've got 12x minus 10x, which will give us 2x. And on the right-hand side, we've got minus 5 plus 9, which will give us 4. Divide through by the 2. And we've got x equals 2 as a solution. Okay, so slightly different at the start, but we end up doing the same thing further down in the solution. Right, let's try another example then. So similar to the last one, but if you notice in this case now, we've got separate terms on the bottom. Okay, in the last question, we had just numbers on the bottom, but the same applies. What we need to do is get everything on the top and then multiply whatever we need to out, get separate terms, get x's on one side, numbers on the other, and there's your solution. Okay, what we've got to remember though, when we cross multiply, we've got to take everything on the bottom here to the top, top right in this case and top left in that case. Okay, you can't just take the x up or take the 1 up or take the 2x there or the minus 1 up there. Okay, when we've got something in this form, we need to take all of this up to the top. Okay, there are a few exceptions when you've got things multiplied on the bottom. but we'll see them further down the line. Okay, but generally you need to take everything to the top in this way. Okay, so let's cross multiply this x plus 1 to the top right and this 2x minus 1 to the top left. So on the left hand side then we're left with 2 multiplied by 2x minus 1, and on the right we've got 5 times x plus 1. So let's multiply this out then. 4x minus 2 is equals to 5x plus 5. Numbers on one side, x's on the other. I'm going to take the x's to the right to give us a positive x. And the numbers to the left, so we've got minus 2. This 5 will come over, become a minus 5. And on the right, we've got 5x minus 4x. Okay, so this becomes minus 4x when it comes over to the right. So on the left then, we've got minus 7. And on the right, 5x minus 4x. And we get x straight out. Okay, so that's the solution to that one. What you've got to take out of this one though is that when you're cross multiplying, we take everything up to the top. Okay, not just individual terms, we take the whole denominator to the top, or to the numerator as it's called, on both sides. Okay, and when you cross multiplying, you don't have to cross multiply both, okay, at the same time. In this case you do, okay, in this example. But just because I'm cross multiplying this to the top right here, it doesn't mean that you have to cross multiply this to the top left. Okay, in this case you do to solve the equation, but it's not the same as multiplying both sides by a number, okay, for example. Right, so next example then. So this doesn't look very nice, does it? It looks slightly more difficult than the last example. Right, so the difference being here mainly, of course, with the last example, we had something in this form, didn't we? And we could cross multiply. So we had something in the form of a over b equals c over d. Okay, so we could cross multiply. But of course, now we don't have something in this form because we've got two fractions on the left-hand side. Okay, so we can't just cross multiply, for example, this up there and that up there. Okay, we can't just do it when we've got separate fractions on one side. If we had something like that, then that's fine. But in this case, we can't. But the same principles apply in terms of getting all the numbers on the top. Okay, we still want to get rid of this 3, this 5, and this 7 on the bottom. So how are we going to go about that? Well, remember I was saying before that we can do anything to an equation as long as we do the same to both sides. Okay, and by doing the same to both sides, of course, it means that we're doing the same to every term. Okay, so if I multiply this side by a number, we're multiplying this by that number and this by that number. Okay, and in doing so, of course, we'd also have to multiply this by that same number. Okay, we've got to be fair to both sides of the equation. So how could we get around this, and how could we get rid of these numbers by multiplying each term by a number? Now, if we multiplied each of these terms by a number that this went into, this went into, and this went into, of course they'd all cancel off, wouldn't they? Yeah, they cancel off with whatever number we are multiplying each term by. So how can we think of a number then that this goes into, this goes into, and this goes into? Okay. And what we're looking for here is a common factor. Okay, by common factor, that means that this and this and this will go into that number. Okay, so it's a common factor of all of these denominators. Now, an easy way of finding a common factor is by either by looking at these and thinking, well, does 3 go into that number? Does 5 go into that number? And does 7 go into that number? You could do that. You might be there a long time. Easy if you've got similar numbers. For example, if these were all 6s, you would think, well, of course, they all go into 6. Hopefully, you would think that anyway. But in this case, it's a bit more difficult. So an easy way of finding this common factor is by multiplying each of these numbers together. Yeah, and by the nature of multiplication, of course, if each of these are multiplied together, that means each of these are factors of that common factor. Okay, so if we do 3 times 5 times 7, get your calculator out if you need to, we end up with 105. Okay, so that 105 now is a common factor of all of these numbers. 3 will go into it, 5 will go into it, 7 will go into it. So with this common factor, what we're going to do now is multiply each of these terms by this common factor, okay? Which we can do because we're being fair to the equation. We're doing the same to both sides. So what we've got then is 105 multiplied by this fraction. So if we put the 105 on the top there, it'll multiply by everything. Of course, this 105 is multiplied by the top of this fraction. Yeah, it's multiplied by everything on the top of this fraction. So we've got 105 multiplied by 2x minus 1 plus, same thing here, 105 multiplied by everything that's on the top of this fraction over 5. So I've got to squeeze this in a little bit, sorry. And on the right hand side, we've got 105 times the top of this fraction. Of course, we've got to do the same to the right hand side as well. So 105 times 1 on the top here will just give us 105, so nice and easy. And that is, of course, divided by the denominator, which is 7. Right, so now things are going to start cancelling. So we've got 3 on the bottom here. So what we're essentially doing to this bracket here is we're multiplying it by 105 and then we're dividing it by 3. Okay, so what that means then is that we can cancel these down. So 3 goes into 105 35 times. Okay, 3 goes into 105 35 times. If you notice, it's just the other factors multiplied together. 5 times 7 is 35, so that's a quick way of working that out. Plus, this 5 will go into 105 21 times. So again, it's the other factors multiplied together. 3 times 7 gives you 21. And 7 goes into 105 15 times. Okay, so we get a nice number on the right hand side. Right, so same situation then as some of the easier linear equations. Multiply these out, get separate terms. So 35 times 2x is 70x. 35 times minus 1 is minus 35. Plus 21 times 4x is 84x. 21 times 2 is 42. And on the right hand side, of course, you've got 15. Okay, so what we're going to do then, as usual, get your numbers on one side, x's to the other. I'm going to take my numbers to the right hand side. Of course, you could group whatever terms you want to here, simplify it out. So on the left then, we've got 70x plus 84x. On the right, we've got 15 plus 35 minus 42. On the left then, we've got 154x. On the right, we've got 8. And then for the final answer, of course, divide through by whatever's in front of the x. Okay, so we've got x is equals to 8 over 154. And if you wanted to cancel that down, it would be 4 over 77. Or as a decimal, 0.05. Okay, so in exam conditions, I would accept any of those answers. Okay, unless I specified, for example, in this case, express your answer to 2 decimal places. Okay, so slightly trickier, but just remember, you always want to multiply by a common factor of these denominators. Let's have a look at another example then. So it looks very similar to the last one. In fact, it's a little bit easier than the last one really, because the numbers on the bottom here, hopefully it's a bit easier for you to find a a common factor between each of these. Right, the issue in this question is this minus here. Okay, so you've got to be careful with this minus. So common factor between each of these, hopefully you can see, is 6. Okay, so it can't be 3, of course, because 6 doesn't go into 3. Okay, so common factor is 6. Or, of course, you could do the same as the last example. You could multiply all these together, get 54, and then do exactly the same thing. Multiply each term by 54. Okay, you get the same answer, but the problem is then the numbers aren't very nice. Okay, so, 54 times 5, 54 times 3, not very nice to do. Okay, so a bit easier for multiplying by 6. So let's do it then. We've got 6 multiplied by this fraction, minus, so be careful of that, minus 6 multiplied by this fraction, and on the right hand side then we're multiplying this 2x by 6 on the top, so we've got 12x over 3. Okay, so just to save a bit of room for me there on the side, we'll go straight for it. 6 times 2x is 12x. Okay, so let's cancel these down then. 3 goes into 6 twice. And it might not look very nice doing these solutions, but you do get down to something pretty simplified quite quickly. So 2 multiplied by that bracket. Now this is where you've got to be careful, okay? 6 goes into minus 6. Okay, goes into minus 6 minus 1 times. Okay, so it's minus times this bracket. Now there's a couple of ways you could write it down. You could write it like that, which is correct. And that would be the way you would generally write it mathematically, to be honest. But in this case, I'm going to write a 1 there. Okay, so minus 1. The reason being, generally, if you've got something that looks like this, people will forget that that minus has to be multiplied inside that bracket. Okay, so put a 1 there and you won't forget it. Right. On the right hand side then, well, we can simplify this a little bit, can't we? 3 goes into 12x, so 3 goes into 12 4 times, so we've got 4x. Right, let's multiply this out then. So we've got 10x plus 6. Oops. So this is the important part. Minus 1 times 2x is going to be minus 2x. Minus 1 times positive 1 is going to be minus 1. And that's equals to 4x. Okay, so people would be, it's quite a common mistake that people would forget to multiply that minus into the bracket there. That's quite a nice way that I try to use in exams to catch people out. Okay, so just beware of that. So let's simplify these terms then, group them together. So we've got 10x minus 2x will give us the 8x. 6 minus 1 will give us 5, and that's equals to 4x. X is on one side, numbers on the other. So let's take the x's to the left then. So we've got 8x minus 4x is equals to minus 5. 4x is equals to minus 5. So x is equals to minus 5 over 4. Okay, so minus 5 quarters, so that's minus 1.25. Another example then that looks slightly different. This is going back to some of the ones we did earlier in terms of multiplying brackets out together. So same thing then, we've got to multiply both sides out, but here you've got a bracket squared. Okay, so just be careful. Very common mistake. Again, it's not dependent on your maths ability. Easy mistake to make. When you're squaring out a bracket, remember you don't just square this term and square this term. Okay, whenever you've got anything squared, it means it's that thing, that term, multiplied by itself. Okay, so x plus 3 times x plus 3. Okay, bracket times itself. And on this side, of course, it'll stay the same. Okay, so a bit like the ones we did earlier then, multiply these out on both sides. So we get x squared plus 6x plus 9. Okay, So I've kind of gone straight for it there, okay? X squared, of course, if we did this the wrong way, it would be x squared plus 3x plus 3x plus 9. Group the 3 x's together and you would get this 6x. Okay, if you notice, these numbers here in this quadratic expression, this one here is these two added together, and this one here is these two multiplied together. Okay, so it's an important thing to notice, especially when we get onto factorizing quadratics in order to solve quadratic equations. Okay, same thing for this side then. We've got x squared minus 3x minus 4. Okay, I did exactly the same thing there. Those two added together, those two multiplied together. X squareds will cancel, and we're left with then 6x plus 9 is equals to minus 3x minus 4. Get the x's on one side, numbers to the other. I'm going to take the x's to the left, numbers to the right, and we're left with then 9x is equals to minus 13. So x is minus 13 over 9, okay, which is minus 1.44. Right, so very similar to one of the ones we did earlier. In fact, we did a couple like this, didn't we? But slightly different because we've got that bracket squared there. Okay, so just be careful of that common mistake.